What's up, RKT team? Welcome back to a math video. You're here with Noemi, and today we're going to be looking at limits. So what exactly is a limit? A limit actually tells us and describes a value that a function approaches as the input get closer and closer to some value. Limits are fundamental to calculus, but yet it's very, very easy, especially for our exams. You will only need to know a few concepts. In most of the question, a rational function will be given with the limit either approaches 0 or approaches infinity. So how does the rule of limits works for rational functions? As x approaches 0, the smallest power dominates because higher power shrink faster than the smaller ones. Whereas for x approaches infinity, the largest power of x dominates because higher powers grow much faster. So when you're solving limits of rational functions, look at the degrees of the polynomials. For infinity, focus on the largest powers. And for 0, look what's happening to the smaller ones. To understand this, let's try some examples. Let's consider our fx equals to 1 over x. We're going to compare the behavior of the function as we approach different limits. First of all, we're going to see what happens as x approaches 0 from the right side, 0 from the left side, and then last, we're going to see as x heads towards infinity. First, let's examine what happened to 1 over x as x approaches 0 from the right side, meaning from the positive values of x. Here, x is positive but getting closer and closer to 0. Let's imagine plugging into a small and a positive number of x. As x gets smaller and smaller, 1 over x actually gets larger and larger. When x is 0.1, 1 over x is 10. When x is 0.001, 1 over x is 1,000. So as x approaches from the positive side, 1 over x shoots up towards the positive infinity. So what happens when x approaches 0 from the left side? Same as the one we looked before, 1 over x gets larger and larger as x approaches 0. But since x here is a negative number, it means that it ends up being a negative infinity. Finally, let's look at what happens as x approaches infinity. As we all know, when the numerator is a constant, the larger the denominator, the smaller the fraction. So this means that as x grows towards infinity, 1 over x gets closer and closer to 0. So let's try out one of the examples in the exercise. In this question, we need to find the limit of a rational function as x approaches infinity. And as we mentioned before, when we see infinity, we are only looking at the highest power from both the denominator and the numerator. So here we're going to have minus 2x squared over x squared. We simplify it, we end up getting our final answer, minus 2. Here's our second example. This one's going to be as simple as the one we did before, but we just got to notice that we need to find the limit as x approaches 0. And I hope you remember that means that we're going to be looking for the lowest power of x, which in this case is 1 over x4. And when x is a denominator as it approaches 0, this number becomes infinitely large. Here's example 3. You can pause this video if you feel like trying it out. Since we are finding the limit as x approaches negative infinity, we are also looking for the highest power here. Therefore, the value of this limit is just x to the power of 4 over x to the power of 3, which equals to negative infinity. So here's the last example of this video. It might look a bit trickier than the ones we did, but let's simplify it first. First, we can use the log rule to combine these two into one log. And after that, we're going to simplify the inside of this log, dividing both the numerator and the denominator by x. Here, as x approaches infinity, both 43 over x and 8 over x actually approach 0, leaving us with ln 1. Since ln1 equals to 0, the limit as x approaches infinity for this particular expression will then be 0. Thank you for watching this video. If you have any questions, don't hesitate to DM me.